Hi all, I welcome you to this session on Tableau Projects, and in this module we are going to see how you can leverage the power of AI to explain data points with a single click on Tableau. Tableau functionalities are based on advanced statistical models which explain data and help you uncover insights you may not have found otherwise. But before we begin, let's look at our agenda for today. So we are going to start out by introducing you to Tableau, and then we are going to see how we can install Tableau desktop on our computer systems. Then we have three different case studies on three different data sets. So first of all, we have taken a foreign direct investment data set, and we're going to analyze it from the perspective of your company and see that in which sector will it be most beneficial to start work so that your company can collaborate with the FDI and become successful. Next, we have a case study on Boston real estate, and here we shall look into a dataset mentioning various factors and outcomes involved in real estate prices in Boston, US, and understand the correlation between parameters and the rates of the plots. And finally, we have a fun little case study on IMDb, in which dataset we are going to conduct exploratory data analysis and understand the relationship between various parameters in the dataset using Tableau. And finally, we are going to conclude this session. So with that, I come to the end of my agenda. So without much ado, let's get started. So first of all, we are going to start by looking at what is Tableau, what exactly is its significance. So let's go right ahead. So Tableau is basically a suite of services which aid in business intelligence of a company. With Tableau, you can harness the power of your data and unleash the potential of numbers. You can choose the analytics platform for your individual analyst, for teams and organization, for embedded analytics, natural language interrogation of your data, and see how your organization can create an impact using that data on the market. From connection to collaboration, Tableau is one of the most powerful, if not the most powerful, secure, and flexible end-to-end analytics platform for your data. It is designed for individuals as well as scaled for the enterprise. And it is not only a business intelligence tool, but it also turns your data into insights that drive action for your company. Now, Tableau has a couple of different functionalities. As I mentioned, it is a complete end-to-end solution for business intelligence. It has a Tableau Prep, which is built of two products, Prep Builder and Prep Conductor. Now, this is a personal data preparation tool that empowers the user with the ability to cleanse, aggregate, merge, or otherwise prepare their data for analysis in Tableau. Then you have Tableau Desktop, which can basically extract massive data offline or from the web and bring it into the memory of your system for limitless exploration in seconds. It is a data visualization tool that helps you get actionable insights out of your data really quickly. And then you can share your insights using the Tableau server or Tableau Online, which is essentially an online hosting platform to hold all your data workbooks, data sources, and more. Now, moving on, let's discuss a couple prerequisites so that you can follow through with this session. You have to make sure that a version of Tableau Desktop is downloaded and installed in your PC or laptop or your system, whatever you're using right now. So for me, especially, I am using the Tableau Desktop public version, which is the free version of Tableau Desktop. It basically has all the functionalities you have for Tableau Desktop, the paid version, but it comes for free, and you can easily create stunning interactive visualization on this platform without any coding. You can explore and interact with the most extensive library of data visualizations in the world with over 1 million user-generated possibilities as well. Now, to download and install the Tableau Desktop Public, you have to first log on to the Tableau Public official website. So first of all, on your web browser, you will have to log in to public.tableau.com, and you will be met with a web page like so. All you need to do is enter your email address, use your work email address, and then click on download the app button, which is this big orange button right here. Now this will start downloading the exe file, for Windows by default because I'm using a Windows PC. And you can see the downloading process in the bottom left corner of your website, which is right here. Now this is going to take some time, so kindly be patient. Now once it's done, you can open the downloaded file. Okay. And you'll be met with a setup prompt like so. Here you can check the box which says I have read and accept the terms of the license agreement, and then you can begin the installation by clicking on install. That will start the installation process, and once the installation is over, it will automatically display the start screen of Tableau. Now the start page of Tableau Public looks something like this. It is conveniently named as Book 1, which basically means it's Workbook 1. And you can connect to a bunch of different data sets by choosing one of the options on this panel on the left. And you have a bunch of different tutorial videos, how-to videos, and visualizations of the day in the panel on your right. So now that we have our Tableau Public downloaded, let's go ahead and look at our case studies and try solving them one by one. I'm sure you must be tired of hearing this again and again, but without much ado, let's get started. So our first case study is going to be based off of a data set on FDI, or the foreign direct investment. For those of you who aren't aware of this term, a foreign direct investment, or FDI, is an investment in the form of a controlling ownership in a business in any country. Now, this is by an entity based in another country. It is hence distinguished from a foreign portfolio investment by notion of direct control. Now, we're going to be dealing with a data set which has various different sectors and the direct investment in them over the years. Now, if you're a company or a startup and you want to venture into a certain economic sector, you obviously will look at the sector which is most profitable to you. Now, our case study is based off of that. We shall look at various sectors and determine which of those will prove most beneficial to collaborate with as a company, as a venture. And we are going to answer a couple of questions along the way, like the maximum and minimum direct funding for a given year. We are going to also find out the trends for direct investments for different sectors and how they can be grouped or clustered together. We are also going to determine the sectors with the highest and least growth in the last 5 years, and sectors which have a little shaky performance throughout the years. We're also going to find out if there is any correlation between certain sectors from an FDI perspective, and are there specific clusters to present the data. And finally, we'll try to forecast the trend for the following year. With that said, let's move on to our Tableau start page and then connect to our data. All right. So this particular file is going to be an Excel file. So I'm just going to go to where all my files are. And this might take some time, so kindly be patient. Okay, now this is our data. As you can see, the first row has sectors followed by all the other rows, which are basically fiscal years and the amount of direct investment per year. Now, as you can see, apart from all of these data cells that we need, we also have a few extras like showing 1 to 64, Power by Visualize, some rows that we do not need, even the ones on top. So what we can do is we can click on this option which says Clean with Data Interpreter, and now finally we have an automatically cleaned data set where we have all the columns and rows that we need. You have all your sectors, you have metallurgical, you have mining, power, non-conventional, coal production, so on and so forth. You have diamond, gold, ornaments, tea and coffee, miscellaneous, and you have the grand total. And then you have the direct investments, made in those sectors along the years. Now we have data starting from 2001 to 2017. Now, another thing is that we don't actually need the grand total, because here we are trying to find out which sector will give us most profit. If we don't take out the raw grand total right now, Tableau is going to start considering it as a sector of its own. So for that, we are going to add a filter. You can always go back to your Excel sheet and clean this up, but my purpose here is to show you how you can do it with Tableau. So what I'm going to do now is I'm going to add a filter. I'm going to click on sectors and then click on exclude. I'm going to check the box exclude right here, and I'm going to search for grand total. Here it is. So I've excluded the grand total row from my data set. I'm going to click on OK. Now, this is the simplest way in which you can clean your data in Tableau. You can also go ahead and click on this link to review the results. What this is going to do is it's going to open an Excel sheet where you have the key for the data interpreter, the data that it has selected to keep. You can look at all those things right here. You can look at the data subtables. Okay. And when you go back to the key for the data interpreter, you can see the different patterns and colors of the cells and what they indicate. For example, the red line indicates that the data is interpreted as column headers. And if you go here, you can see that the entire row number 5 is basically used by Tableau as header. And that's all there is to it. Let's close this and go back to our Tableau dataset. Now let's look at what we can determine using the data that we have. Now, before we begin, I'd also like to point out something, that the data we have is presented in a wide format, which is usually the most common type of representation of data. Government datasets and institutional datasets are usually presented this way. Now, the problem with this type of format is that it is good for viewing purposes if you're just going to go ahead and look at numbers. But from an analysis standpoint, this quite doesn't hold. So what I'm going to do is I'm going to convert it into a long format. So I'm going to start out by clicking on the year 2000 to 2001, and then I'm going to go all the way to the end and press Shift and click on this. This is going to select all of the year columns. Then on any column, I can just right click and select the option Pivot. And as a result of that, we have 3 rows. Now what I'm going to do is the sector remains sector. Pivot field names I'm going to rename into year, and the pivot field values I'm going to rename into FDI. Now what happens if we do this is now we are going to get all of our columns under dimensions, through which we are going to have a little more freedom to play around with our data, which would not have been possible if we had chosen the wide format to work with. Yes? Okay, so another issue I have is the representation of year. Here, the year is given by a start value and an end value, which I think I'm going to change. Now, this is great for viewing purposes, but I wouldn't prefer it for carrying out data analysis. Now, this might differ from case to case, and you might feel differently. There's nothing wrong with this. It's perfectly fine. It's just not in a way in which I would prefer it. So what I'm going to do is I'm going to add a calculated field. Since we've already named it year, I'm just going to call it fiscal year or financial year. You can also call it FY. And we should be using a function known as left. So I'm going to put in year, comma 4, and at the bottom it is going to show the calculation is valid. So basically what I did was I'm excluding all characters from the left after the 4th space. So when I apply it, you can see my fiscal year only has the first 4 characters of every year, which is 2000 in this case and 2001 in the next. And now I have no use for this particular column, which is the regular year column. So I'm just going to hide the column. Now I have all 3 of my columns ready to go, and I think I'm pretty satisfied with my data. With that, I'm going to move on to my worksheet. I can see all of my dimensions and measures here on the left in the data pane. Now, for those of you who are new to this is what a Tableau worksheet looks like. On the left, you have all your data in the form of dimensions and measures. We're going to play around with that. And then you have a couple shelves having rows and columns, which is exactly how it is in Microsoft Excel, except for here, you can be pretty specific and drag your dimensions or measures into rows and columns, and your rows and columns are going to change from context to context. Then this is our canvas. This is where the visualizations are going to be viewed. And on the left, you have pages, filters, and marks. Now, these are the cards which are going to help us create more intuitive visualizations out of the ones we already have. On the right top corner, you have the Show Me option, and right now you can see a couple of grayed out visualizations. But once you have data appropriately input into the rows and column shelves, it's automatically going to highlight the graphs that you can make out of it. So yeah, with that, we can get started. Right now, I am going to go back into my presentation, and here you can see that I have already figured out a couple of questions that we are going to answer through this exercise. So first, let's focus on the first 2 questions, which is determining which sectors receive the maximum direct funding or the minimum direct funding for a given year. Both of them are questions of the same nature. So let's go ahead and find out. So basically now what I'm going to do is I am going to drag my sector dimension into rows right here. And you can see that all of this has been arranged in alphabetical order. It's not in the order that was presented to us in our data set. Yeah. Then what we're going to do is we're going to get our FDI value and drag it to our table. If you hover on the table, you can get the various FDI values. Now, all of these values are in crores because this is based off of India. For people who are based outside of India, 1 crore is basically 10 million. So you can go ahead and do the math. So the question said we needed to find out the maximum and minimum values for a given year. So I'm going to drag fiscal year into the filters, and here it's going to open up a fiscal year dialog box. I'm going to go down, click on 2016, because in cases like these, we usually prefer the latest data. And I'm going to click on apply and then OK. You can just go ahead and click on OK. And then if I go up and click on either of these sort buttons, for example, I'm going to click on the sort button for descending order, you can see that my entire sheet has been arranged in a descending order. And now I can see that the 5 sectors which get most investments include the services sector, telecommunications, computer science and hardware, trading, and electrical equipment. And at the bottom, we have photographic raw film and paper, mathematical surveying and drawing instruments, defense industries, coal and coal production. Now, this is a great information if you're suppose an analyst or you conduct market research. This is actually great information that you could go ahead and give to your managers so that they know which industries to invest in. Of course, this is not the only factor. There are going to be many factors which we are going to discuss through the course of this project, but this is simply one of them and the most fundamental, if I might add. So now if you want to take up this list to your manager and say, sir or ma'am, these are the industries in which we should invest, you obviously would not take the entire list to them. Obviously, you would take the top 5 or maybe top 3, top 10 of the sectors that deserve to be invested in, right? So for that, what we need to do is go on filter, go to edit filter. Here we're going to select all and then go to top and click on the option by field. As you can see, it says top and then it says 10. I am going to change this to top 5 and change the sum to maximum. And I'm going to apply that value and click on OK. Now, you might have noticed that the order of the sectors has changed, and that's only because we have selected all the years instead of just 2016, which was previously selected. So you will see right now that the top 5 is not being filtered out. And that is because we have not filtered out our sectors. So we're going to drag the sectors into the filter. And then we are going to this tab called top, select by field again, top 5. And then apply it. Okay. And now in front of you, you have all the top 5 performing sectors in which there have been most foreign direct investment. And I'm also going to rename the sheet. Let's call it Max FDI because, it's always great to be organized. So with that, let's move on to our next worksheet. For that, I can just click on this new worksheet button, or I could do something else and I could duplicate the Max FDI sheet. Now, what happens when you duplicate a sheet is that all the filters that you have applied on the previous sheet, all the calculated fields, get copied along with the sheet, which is why this is a greater option if you have to make minute changes and don't want to apply all those filters again. So I'm going to rename this instead of Max FDI 2. I'm going to rename this into Minimum FDI. And all we have to do is we are going to edit the sector filter. And instead of the top 5, we are going to select the bottom 5 and click on apply. And here we have the bottom 5 values, which are industrial instruments, coal production, so on and so forth. So now that we have our maximum and minimum FDI sectors, next what we have to do is we have to see if there's a trend for direct investments for individual sectors. And what I'm thinking is we could make a filter for individual sectors. We should be able to filter out different sectors. So now to determine trends, I am going to move on to sheet 2 and I'm going to again rename this as overall trends. All right. So what I'm going to do right now is I'm going to drag my fiscal here to the columns and the FDI value to my rows. So almost intuitively, Tableau has turned this into a bar graph. But since we are showing trends, I think a line chart would be more apt. But if I drag down here to the line chart, either of the line charts, it basically says it needs one date. Here at the bottom, you will see requirements for a chart. So if I hover on line chart, you can see for lines continuous, try one date, 0 or more dimensions, 1 or more measures. Now we already have our date, so why aren't we getting the line chart option? Now majorly because our fiscal here has been imported as a text format. So basically we're going to go on the drop down arrow, change data type and convert this into date. And the moment we convert it into a date, it automatically turns into a line chart almost instantly. And we get the trends from 2000 to 2016-17 with our line chart. And it's a clear indication of what has happened. This also might be the reason that sometimes you might have taken up the date as one of your columns, but you still don't get the option for a line chart. You can go ahead and check the data type in which your date column is imported. And if it's not date, you can turn it into date or datetime, and you will open up the option for a line chart. Now, what you can see right here is a couple of high points, 2008, 2011, and a couple of down points, which start at 2008, the downfall, and go down 2009 and 2010. And I think it's pretty obvious because 2008 and 9, the fiscal year of 8 and 9, was actually the year of the global economic crisis and global recession. So it makes a lot more sense if you think about it that way. And then it shot back up in the year 2011 and carried on to our current fiscal year, which has most FDI value, 2016 and 17. Now, if you wanted to make the chart a little more interesting, what we could do is we could bring down the FDI values and maybe drop it on label. This way we have labels on all of our data points, and you can see how the FDI values have changed over time. It started with some 2,400 crores, and now it's at 43,000, nearly 500 crores, or you could call it 435 billion. You can see all the trends changing overall, the highs, the lows, the little bit of recovery after the 2008 debacle here in 2011. With that, we have our overall trends. Moving on. So now if I go back and see what next, I see that we have to find out the overall trend for individual sectors. So for that, we obviously have to use a filter. Let's go back and finish what we started in the overall trends. So putting up a filter is pretty simple. You can either drag your sector dimension into filters, and you will get a filter based off of sectors. Then you can select all, apply, click OK, and then you can right click on the blue pill which says sector and click on show filter. Then it'll show the sector on the right. Or you can simply click on the dimension sector, right click, and use show filter. Then if I clear all the check marks, I can just go on individual sectors and see how they have performed throughout the years. Let's take education, for example. As you can see, there has been great investment in education in the year 2013, closely followed by 2015 and 2008. But since we have applied this filter, this particular line chart type is kind of odd to be looking at. So what you can do is you can click on path in the marks card and select the kind of line you want in your line chart. So one of the options is this jump line chart, but what I really like is the step line chart. Here you can see individual rises and falls of every sector that you choose. If I cut out on education and I click on the search button here and select maybe railway, even railway has seen massive growth between the years 2013 and 14. I wonder what happened. Was it the year of the election? Was it the year after? I am quite leaning towards a change in political parties in power. If you guys know what happened in 2013 which affected this change, do let me know in the comment section below. Maybe let's try food. Click on food processing industry again. Between the year 2013 and 14, you can see a massive growth in the investment in the food processing industries. And with that, I go back to my general line graph. I think I'm going to keep it this way because I quite like the whole step line graph. It will also look good on my dashboard, I think. Okay, so now let's go back to our presentation and see what do we have to do next. So the next actionable item is to group certain sectors together based on similarities. So I'm going to go on to sheet 4 and I'm going to get all sectors here. If I right click on the sector pill in the dimensions, you can see the create option where you get options like calculated field, groups, and sets. I'm going to create a group, and here I'm going to find similar looking groups and group them into a single group. So I'm going to group agricultural machinery and agricultural services into one. I'm just going to call it agriculture. And similarly, I'm going to make a couple more groups just to show you guys. And once I click on apply, you can see that we have the groups that we had made earlier right up top here. And if we bring our FDI values, we have combined values from all the sectors that are present in one single group. And that's as simple as it is. So I'm going to rename the sheet as groups. So moving on next, let's see what else we have to do. Okay, so now we have to find out sectors which reported highest growth and highest decline in the past 5 years. For that, new sheet. And then I'm going to drag the sector dimensions into rows. And I'm going to drag fiscal year to the columns. Just going to drop the FDI value in there. And as you can see, remember the first few numbers so you can see the change happening. What I'm going to do is I am going to change the measure from sum. I'm going to go on quick table calculation and change it from sum to year-over-year growth. And now, as you can see, all of the numbers we had changed into percentages, except for 1 year, which is 2000. And obviously, you cannot see year-over-year growth for 2000 because we do not have the data for 1999. So now we're going to drag our fiscal year into filters. And now you can see we have our latest 5 years, but 2012 is not going to show any values. It has a completely blank column because of the same logic that I had mentioned earlier when all the years were in display. Because we filtered out all the years before 2012, by that comparison has no year-on-year growth. So we are going to change the top 5 into top 6. So we actually get our top 5. And voila, we have 2012 through 2016, and we have the latest years. And now what I'm going to do is I'm going to click on this row, 2016, and sort everything in a descending order so we can get our top 5, which is glue and gelatin, cement and gypsum, scientific instruments, electrical instruments, and telecommunication, which are giving us the most year-on-year profit. And then I select this filter and go on top 5, and this displays my top 5. Now that we have our top 5, let's duplicate this so we can find out our highest decline, in which case I am going to change this filter, edit the filter, and instead of top, I'm going to go for bottom 5 and apply. And as you see, the bottom 5 sectors are defense, photography, mathematical and surveillance, choir, and coal production. What happened? Defense industries in 2016, almost a negative 100% growth. It's kind of a shame. People, please go join the defense. I could if I would, but I can't. But you guys can. So go give the direct investment something to invest in the defense. So with that, we have our highest growth sectors and our highest decline sectors. So next, as far as I can remember, we had to show maximum variance. For this, I am going to rename the sheet. I'm going to call it variation. And one of my favorite charts to do that, to show variation, is this box and whiskers plot. I can never remember the name. So what I'm going to do is I'm going to drag sectors to columns and FDI values into rows. And then I'm going to go into analysis and uncheck the box. Okay, so I basically switched them up. I kind of like this view better. Then what I'm going to do is I am going to arrange this in a descending order. Here, if I hover over a certain box, I can see the upper whisker, upper hinge, median, lower hinge, and the lower whisker, which obviously clearly is a lot for the services sector. But I'd like to point out something more interesting. If you see the second and third boxes, now the second box has an upper whisker of 2613 and the median is 872. The third one, which is constructional development, clearly has a higher upper whisker, but the median is lesser than that of computer softwares, which is actually why it comes on number 3 and not on number 2. And things like that are what make these statistical graphs more interesting. These are also called the 5-point graphs, basically because they give you 5 points from a separate sector or factor or whatever your data is. So we have our maximum variation, which is the services sector, and the minimum variation, which is this 𝐄𝐝 or 𝐄𝐝 or however it is pronounced. I don't know. This is a Tableau video. Moving on. So next we are going to find out what is the proportion of investments between sectors from the FDI's perspective. For that, very simple, we are going to have a tree map. I'm going to move on to the next sheet and rename it as portion of FDI. And for that, basically, I am going to give sectors and FDI values. And I'm going to select the tree map, and it makes everything pretty visible. So I'm pretty happy with that. You can also put fiscal year in the filters here. Show filter on the right. Here you can see the filters. Now you can see year by year proportion of investment in a particular sector, let's say computer software and hardware, was at top of its game in 2005, but in 2016 it was taken over by services sector. I think this is the clearer of the graphs. So now that we have the proportions of investments, let's move on. So there's a lot of visibility in here. We can see telecommunications, trading. So moving on, let's see if we can find out specific clusters present in our data. For that, I'll bring in the sectors. And obviously, we are going to bring the FDI values in here. Now, if we switch from the data to the analytics pane, you can see in the model category, only cluster is enabled. So what I'm going to do is I'm going to drag the cluster and bring it right here. If you see on your right, it automatically has made 11 clusters on its own, but here you can add the number of clusters that you would like. 3, 4, 5, 7, any number of clusters. But simply put, this is basically going to categorize all of your sectors based on similar properties. So now we are going to close this, and you can see from our data, Tableau has picked out 11 clusters. That means all of our, I think, 100 or something, nearly 100 sectors can be categorized into 11 different clusters based on their similarities and how they attract their direct investment. And the values are color coded according to the clusters. But this is going to take me a lot of hard work to sift through, and I can't even imagine showing this to somebody else, for example, my manager or stakeholders of the company. So what I'm going to do is I'm going to click on the Show Me tab again, and at the bottom I have Packed Bubble Chart. I'm going to select that, and this makes it way more visually appealing. We can see how many of our sectors are colored in the same color, which represents the cluster they are in. You can see that cluster 9 and cluster 11 have just one sector each, while cluster 5 includes computer hardware, construction development, and telecommunications. It's pretty self-explanatory. I think we can also filter out the clusters. Let's see, what is cluster 9? Cluster 9 is the power sector. Pretty understandable, isn't it? And cluster 11 is the automobile industry. Yes, again, pretty understandable. Now, finally, we have to forecast the trend for the following year. And for that, we are again going to open up a new sheet. I'm going to name it Trend Forecast. So again, for the last time, I am going to get my fiscal year to the columns and FDI values to the rows, and it automatically within a matter of seconds turns into a line chart. So if I go into the analytics pane again and click on forecast and I drag it to my canvas, it almost intuitively, immediately gives me a forecast for the year 2017. The end of year 2016, it says the value is going to drop to 39,000, and in 2017 it's going to be 41, and 2018 it's going to be 44,000. Now this is just an estimate with the upper limit and lower limit grayed out in a lighter blue shade for the next 2 years. Now, what could be fun is maybe if we could find out, say, sector-wise forecasts. So I am just going to add a filter, and let's see. I work in IT, so I am going to check the computer software and hardware. And it seems like it will go from nearly 6,000 crores to almost half. That's kind of sad. Now let's move on and see something else. Let's see what our leading sector has to offer. Let's select services, and it comes down almost significantly as well. So another way of doing this is the trend line. So in the analytics pane again, you're going to drag the trend line and add a linear trend line. This basically is a linear equation. It says to get the FDI value at any given certain point, you have to use the equation given for FDI value, which is a pretty big number. The R squared value is 0.79 or 79%, which basically means you can depend on it. And the P value is 0.0001, which, let me tell you, according to hypothesis testing, if it is less than 0.05 or 5%, you can basically depend on the value. Some basic statistics, and that's exactly how you can forecast the direct investment per sector for the coming years based on the data that you already have. Now, there are many other methods through which you can do this. Now, this is just by using this BI service. And with that, we've answered all of our questions. Now, all there is left to do is create a dashboard for presentation purposes to your manager or your stakeholders or your customers, whoever you might want to show it to. So for that, I am going to create a new dashboard. And all we have to do is drop sheets here and resize them as we go. All right, with that, we have our dashboard. This is our page 1. I've added a text box here, which gives us the name of our overall workbook. I've named it Insights on FDI Data. You can name it however you like. We have the proportion of FDI, the clusters, the trend forecast, and on page 2, we have our overall trends with highest growth and decline. We have individual filters on each of the pages and individual cluster filters on page 1 with indicators of the forecast here as well. With that, we come to the end of our FDI case study. With that, our project 1. Let's move on to see which case study do we have next. Now for our second case study, I have a data set of the Boston real estate. Now, this was a data set which was taken maybe in the 1960s to see how different factors, different parameters are involved in the real estate prices in Boston, and understand the correlation between various parameters with each other. Through this exercise, we will try to find out how crime affects the price of real estate, how is the age of the building or the proportion of owner occupied and establishing building affect the price of the estate, how are number of rooms related with the price of the flat you take, and how these rates vary in time. Basically, we are going to create a couple of KPIs which are going to help us make a decision regarding purchasing a plot in said real estate. So without much ado, let's move on to our Tableau desktop. Here I have already connected to the data. It is a CSV file. And here you can see all the different variables, all the different columns which have different parameters. We have crime rate, we have the NOx rate, we have age of the buildings, we have tax, we have the pupil teacher ratio, we have the proportion of lower income class people living in a certain area. And finally, we have the median price of said plot. So we are basically going to find out how do people in the industry determine the prices of a certain plot in Boston. Pretty simple. So with that, I'm going to move on to the first sheet. You can see all your variables, all your measures here on the left as usual. So on sheet number 1, I'm not going to create any visualizations. I'm going to start out with clarifying all the variables and what they mean. And I'm going to put it up clearly here in place of its sheet name text. And I'm also going to rename this sheet to variables. So because I know all the names of columns are not very clear, here I've put them up clearly. Okay, let me just quickly put in some. So here I have specified what each of the variables stand for. So the first one is per capita crime ratio. Then ZN is proportion of residential land zoned for lots 25,000 square feet. Then next we have proportion of non-retail business acres per capita. Then we have NOx, which basically weighs the concentration of nitric oxide in parts per million. Then we have average rooms per dwelling. Then we have proportion of preoccupied houses which were occupied before 1940. Then we have distances to Boston employment centers and again distances to radial highways. Then we have the full value property tax per $10,000. Then we have the pupil teacher ratio per capita. Then we have proportion of segregated minorities as well as lower income class in every area. And finally, the median value of homes in a particular estate. So now that we know what all of our columns stand for, let's go ahead and start visualizing. So let's start out by opening a new sheet. So first I'm going to bring in the price or the median value. into rows, and then let's see its relationship with crime. Now, as you can see right now, we can only see one data point. If this is happening with you, all you have to do is go to analysis and uncheck the aggregate measures box. So it gives you an unaggregated view or an unaveraged view on your screen. You get to see all of the data points that exist. So suppose I don't want to know about crime. I will want to see where the median pricing moves if I correlate it with pupil-teacher ratio in every school. And here we can see there's no such rising or falling relationship. Let's try something else. Let's bring taxes. All right, as we can see here, we are getting somewhere. So once we have our average number of rooms per dwelling, we can see that it shares a positive relationship with the median pricing. So now basically I want to give this power to my user. I want all these visualizations to be at his or her disposal. So what I'm going to do is I'm going to go to the dimensions pane and click on this drop down arrow and click on create parameter. So I am going to call this measure of interest. And keep the data type as string. Click on list. And I'm just going to add as I go, but currently I am just going to put in some of the main measures. So let's see: age, crime, average number of rooms, tax, nitrous oxide, teacher ratio, and like radial connectivity. That's very important. Then I'm going to go right click on the parameter. Once your parameter is created, you can see it here at the bottom under parameters, and I'm going to right click and click on show parameter control. So then you can check out your measure of interest and how it relates to the pricing of a particular area. But you will notice that this is not working right now. And that is because we have forgotten to establish a connection between said measure of interest with the pricing. So again, we go to dimensions and we click on this arrow and create a calculated field. We'll just call it So we're going to write a case statement, a pretty simple case statement. Basically, what we are trying to tell Tableau is that when we are selecting a certain option, we need it to use that option as your column input. Let's see, what all have we put in our measure of interest? There's age, crime, tax, NOx, PT ratio, right? And finally, we are going to end it with an end statement and apply it. Here on the left under measures, you can see measure of interest, which is our dynamic measure. And then we are going to click on OK. Then we're going to switch out this column from rooms to measure of interest. Remove this. And then we're going to see if our pricing is in average. So for these kind of analysis, usually your pricing needs to be an average. Everything else also needs to be an average. And that's it. Now let's see how tax affects your pricing, followed by crime affecting your pricing. As you can see, where there is zero crime, the prices are really, really high, which is very obvious. And here is the radial distance to your highway, pupil-teacher ratio, which is kind of more evenly distributed along the canvas. And that is how you create a dynamic measure to determine the effect of various parameters on the pricing of a certain plot. Now that answers the first few questions in our case study. Next, we are going to see how do rates fluctuate based on the crime rate in an area. So here I'm going to introduce you to something known as bins, where basically you are going to create bins of say 3 or 4. You're going to club 2-3 numbers together, create categories basically. So here I'm going to introduce you to something known as bins. Bins are nothing but ranges. Suppose your crime index is on a scale of 10. You can club the first 3 together, then the next 3, like 0 to 3 together, 3 to 6 together, 6 to 9 together. That's how you're supposed to read bins. So here is the green pill, the crime pill. I'm going to right click, go to the create option, and then bins. As you can see, it automatically suggests bin size as 3.3. I am going to keep it as just 3. Then OK. And right up in the dimensions, you can see that the crime bin has been created. So I'm going to bring this to the columns and then put in the price for rows. And it automatically brings me this bar graph. But here is one column with null value. So we are just going to exclude it. Yeah. But I'm still not happy with the representation. So instead of this, I'm going to change it into a box and whiskers plot. I'm going to make a few changes, bring this right here. But as you can see, this does not open up. So if you face a situation like this, so you can basically go up to the median pill and select dimensions. And that will give you the proper cats and whiskers or the 5-point plot. And it happens so because dimensions, this option that we selected, the dimension option basically brings out all the points, whereas a measure aggregates all the points to one. Yes? Now you see the median price of an area which lies in the crime index 0 to 3 is as high as $23,000. And here are a couple outliers which go even higher, and the highest price somebody is ready to pay is $50,000. And this just gets lower and lower as crime increases, and you can see there's a direct relationship between crime and pricing of a certain plot. And you can do this with all the other measures that there are, but crime rate or crime index is a really important parameter for people to choose a locality in which they want to live. So now let's go ahead and add a few metrics to this workbook. So for the KPI, I am going to drag out the measure names pill here and then maybe the measure values. This immediately gives me a bar chart, which is okay, but I don't think it's an apt way of representing this data. So I am going to convert it into a metric form, a table form. Also, for the sake of creating a dashboard later on, I am going to swap out the rows and the columns, and this gives me a swapped version of the previous metric chart, and I can choose to pick as many or as few of the parameters to display in my dashboard. Also, it doesn't really make any sense that all the measure values are there in our sum form, so I am going to convert them into average. You can see all your metrics change. This makes more sense. I'm not interested in all the measure values, so here I'm going to keep only my top 5 measure values, which I think is relevant if I had to pick a house. So age of occupancy is really important. Rest. This I'm going to remove. Crime distance. The dynamic measure also I'm going to remove. All right. Now, how do you make use of it? What I'm going to do, I'm going to bring out the price into the filter. And hence you can see all the values, pricing. Suppose I'm interested in a house between 15 and 25,000. Here I can see my average crime rate is 1.8, average distance to a workplace is 4.1. I have average nitric oxide in the air, pupil teacher ratio, so on and so forth. And that is how you turn these basic metrics into key performance indicators to make decisions on whether you want to buy a plot in a certain area or not. And this can be used to create an application out of it for user benefit. Suppose you're working in real estate or your company has stakes in it, you're an analyst, you have to conduct your market research. This is how you can give all the power to the user and enhance user experience using Tableau. So how to enhance this metric further? What I'm going to do is I'm going to create a calculated field and call it crime indicator. And here I'm going to write a very simple if statement based on the crime bins that I created. So let's see. Crime is less than equal to 3, then it's going to display low. Crime is less than equal to say 8, then moderate. Is equal to else high. All right, so now we have our crime indicator. This makes it easier for your viewer and enhances user interaction with this particular application. It also makes it easier for people to read out rather than looking at lots and lots of numbers on your table. So I'm just going to apply it and click on OK. So for this to show, I'm going to open a new sheet. So I'm going to select this crime indicator and the price. And this table does not do it justice. I'm going to make it a pie chart, and to make these colors more indicative of the crime in a certain area, I'm going to change. For high, I'm going to keep it red. For low, I'm going to keep it green, and for moderate, let's keep it yellow. Let's turn them into a complete traffic signal. I'm going to apply it, and as you can see it in the crime indicator box in the right. Also going to bring the price filter out and show filter. Okay, so now if I set up a range, say 15 to 25, you can hover over it and see the crime indicator for different median values. Moving on, let's see if we can find out an equation between various factors and the price. Going on new sheet. And equation. And here I'm also going to bring in my price, and I'm going to pick crime again. And this will give me a scattered chart. What I'm going to do is I'm going to go to analytics and select a trend line under the model. And my scatter chart looks more like logarithmic chart, so I'm going to use that. And you can see when you hover over the logarithmic line, you see an equation for crime, and you also find the R squared value and the p-value. The r-squared value is 0.28 and the p-value is again less than 0.05, which is 5%, which means that you can trust this equation. This is a usable equation. Now, if we switch, let's see, the crime for the Knox value, you can see the equation has changed. The r-squared value has come down to 26. So now basically we are trying to predict the Knox value, but if I go ahead and swap the two, here you can see how the increase in NO2 affects the price of a certain real estate. If I go up here on the line, and here you have the logarithm, and if for a moment I change this into a linear model, you can see a formula for your price of a certain estate, which is minus 33.9161 times Knox plus your 41.34, which is nothing but an intercept, with your r-squared value at 0.18. This basically is how much your Knox value is going to affect your pricing. And then you have your p-value, which, as I had explained before, is the value you get from hypothesis testing. Now, this worksheet is a great way through which you can find out how certain factors affect the pricing of real estate. I have taken Boston, for example. You can pick any data set that you like. You have your equation for predicting price based on the Knox value. Your r-squared value is 0.18, which just means you can barely use this variable as a complete indicator for price. You have your crime indicators, you have your metrics for the 5 most important things people look at while determining the pricing of a certain real estate. You have your crime rate versus building pricing in boxes and whiskers plots. Here you have your dynamic measures affecting the price, and this is your personal help page for all the variables. All in all, this is a pretty useful method to make decisions by creating key performance indicators and dynamic measures. Let me go back and check if I have uncovered the entire case study, and I have. So to conclude, we basically studied a data set which had multiple factors affecting the prices and the outcomes of pricing on multiple parameters in a certain area. And we understood the correlation between parameters and its rates. With that, let's move on to our next case study. So the third and final case is based off of a data set on IMDb. Here we are going to conduct statistical data analysis or exploratory data analysis on the data set and understand the relationship between different parameters or factors in the data set. We have a couple of movie budget and revenue related questions, genre related questions. We also have a few correlation questions between the revenue generated by the movie versus its impact on social media. So all in all, this is going to be not a step-by-step kind of a solving like we did for the 2 previous case studies. This is going to be focused more on the implementation side. It's going to be slightly more fast-paced since we have already done like a step-by-step in the previous 2 case studies. I would assume it's safe to be presumptuous about you guys being able to catch up. So let's get started. So here's my data set. We have color or no color, director name, duration, Facebook like, names of all the actors, and if we go here, as you can see, all the movies have at least 2 or more genres separated by pipe separators. So we're going to right click and click on split. So now basically all the genre has been split into 3 different columns. But if you want more columns, you can just right click on either of these and select custom split. So I'm going to hide the genre. Here you have a few numbers from Facebook, the IMDb link, country of production, budget, so on and so forth. So let's look at our first question. Is there a relationship between movie budget and revenue? So we're going to start out with sheet 1. So normally we would assume that a high budget movies generally make higher revenues, but we can be proved totally wrong through this analysis. So let's go ahead and check it out. So let's go ahead and bring our gross versus budget. And here, as you can see, again, it's showing us only 1 point, which means we go to analysis and we uncheck the aggregate measures. But I still can't understand anything on the scatter plot because all of these points are so closely gelled in together. And we have a couple of outliers. We have 1 point which has a budget of, I don't know, 12 billion? Yeah, it's 12 billion, which I'm pretty sure might be a mistake on the typist's side, but maybe if I click on this and I go on detail, then I see that the movie's title is The Host, and it gives all the other factors and parameters for the movie. So what I'm going to do is I am going to put up a filter for budget. I'm going to show filter so I can drill it down to at least see some points. If I bring it down to 9 billion, we have these many points. And if I go further down, I can see all these points. And you can go ahead and make all of these changes. And this is how you play with data. And if you can't see your data points, it's a futile exercise. With that, let me open the second sheet and we'll go to the second question, which is about the duration outliers in various genres of movies. So for this particular question, I think it will be most apt to use the box and whiskers plot. So I'm going to bring in the primary genre and I am going to put that against the duration here. This brings down one of them. And as you can see, we see most number of outliers in the drama genre, but we have the most significant outliers in the crime genre, which let's see which movie this is. Oh, and it's the movie Trapped, and it's an Icelandic movie. So yeah, that's about it. The music genre seems pretty consistent. So does sci-fi, which is surprising. You can click on either of these points and check out which movies they are by clicking on view details and look up those links and download them and watch. Who knows? You might just have a movie night tonight. We are going to rename this duration outliers. With that, we are moving on to our next sheet and next question. So according to this question, we have to find out the distribution of various movie durations. So for this, we are going to go for a histogram type chart. So I'm going to bring in the duration and I'm going to create a histogram, and as you can see, it is a basic histogram which is skewed a little bit towards the right, and in the duration bin of 99 minutes you have the maximum number of movies. Moving on. Now we have a couple of questions on social media's impact on the performance of a movie. We have the relationship between Facebook likes and the impact of it on revenues. We have relationship between the likes and IMDb voting. So we're going to go ahead and try all of that. So first, let's create our Facebook versus revenue. So we are going to call this. So we have a couple different like bins. We have cast total like, we have director Facebook likes, we have the movie Facebook likes, and this is the one we will be needing. And as you can see, we again only see like one. Yeah, and with this, you can see that there's actually a linear relationship between the gross revenue and the Facebook likes. Similarly, we had the question for Facebook versus IMDb voting. And we're going to do the same thing. We're going to go for the IMDb score as well as movie Facebook likes. And here we can see that the IMDb score actually affects the Facebook like. It's pretty linear till IMDb score 5, and then it goes up after 5 in a sort of polynomial like fashion. So if I can go on analytics and bring in a trend line, we can see it goes up in a polynomial like fashion. This will also give you a formula for the Facebook likes for a certain movie as well. It is a fairly long formula, but we're going to deal with it. So that covers our Facebook versus revenue and Facebook versus IMDb. Let's go on to our next question, which is to create a correlation matrix between various numerical data points. So correlation matrices actually comes off as really complicated in the end, but it's actually really simple to pull off. So let me start with two numerical data measures. I'm going to start out with budget and duration. By now, you know that if somebody is asking questions about two different numerical measures, the answer is always a scatter plot. Okay? So budget and duration. Now I'll just go on adding measures to it, and it will keep building various different plots, giving us a lot of information about everything that we need to know, correlating all of the different numerical measures that there are. Just go ahead and keep adding, and I'm going to change this to fit entire view. And all of a sudden, within a matter of 10 seconds, you have so much data, the correlation between duration, budget, gross revenue, the IMDb score, the Facebook movie likes with the duration, so on and so forth. You have so much information which is going to take you hours to make sense of. But what I had to show you is that within less than 10 seconds, we basically created this correlation matrix. Moving on, we have, this is an interesting question, is the genre budget changing with time? So what I'm going to do first for this is I'm going to search for the title year, and I'm going to change the data type into a date. Bring in the budget as well. And this automatically gives us a line chart. But this is for the entire budget. What we want is A, the average budget, and B, the budget per genre. So I am going to take the primary genre and I am going to put up a filter on the right. So we can see how the average budget has changed with respect to time for action genre or maybe animation genre. You have comedy, you have crime, you have documentary, you have neo-noir films, you have family, you have sci-fi movies, so on and so forth. Next, we have the distribution of IMDb ratings amongst various genres. So what we're going to do is we are going to create a bin for the IMDb score. And then we are going to bring down genre over here. All right. With that, we can see that action movies are leading the pack, followed by adventure, animation, biography, comedy, and crime in terms of IMDb ratings. Next, so what is the most revenue fetching category for a movie? So for this, we are going to do something very similar. So by category, we actually mean content rating. So content rating revenue. We're going to take content rating and cross. And then this is also a way, this is an okay way to show it, but there is nothing intuitive about it. There is nothing that pops in this. So what we're going to do is we're going to clear this out and we are going to go by year. Okay, and with that, we can see that PG-13s are actually making a lot of money, but what's making more money than that is the G rating. And with that, we arrive on our final question, which is to show Facebook ratings relationship with the movie rating. So again, this is our final sheet. I am going to take the IMDb score versus Facebook likes. And again, I hope this is coming back to you. Every time you have a question related to numerical measures, you are always going to go for a scatter plot. Let me show a trend line as well to show the positive trend. And it gives you a formula for movie likes, and we can actually duplicate this and then flip it over to again find a formula for IMDb score as well. And with that, we found out how various factors affect the budget and revenue of a movie. We have graphs for budget and revenues, duration, Facebook versus revenue, IMDb ratings, correlation matrices, the budget per genres, the IMDb ratings per genres, so on and so forth. And finally, we have a correlation between Facebook and IMDb and vice versa. You can go ahead and make a dashboard out of this, but this is all I had to show you. And this is just the tip of the iceberg of how you can explore data using Tableau. Remember, Tableau is a very powerful suite of services, and the more you work on it, the more you play with data, the more powerful a tool you will acquire through Tableau. I shall leave you with that thought. Thank you and have a great day.